Hi everyone, welcome to my channel Design with Rusbe. Continuing with CSWA practice problems, today we'll work on question 2.2. Let's take a look at this question. So in this question, unit of measurement is millimeter gram second. Like always, when we start working in SolidWorks, we need to ensure we are using the same unit of measurement. Now, looking at the pictures that we have here, we can clearly see that the geometry is not symmetric. We have different features in different locations. We also have four views here. We have the top view, we have a front view, we have a 3D model, and we have section AA. There's also a hint provided in this question. What is mentioned here is basically they're saying that the thickness of the edge is constant everywhere. If you look at the top view, you can see that we have the edge around the geometry. And here you can see that the thickness of the edge is 1 millimeter. Basically, they're saying that this 1 millimeter is constant everywhere. Now, with this introduction, let's go to SolidWorks and start modeling this part. So in SolidWorks, first thing first, we need to check unit of measurement. And you can see in the right corner that the unit of measurement is millimeter gram second, which is the correct unit of measurement. So we are good to go. Now, in order to start modeling this part, I click on Sketch. I click on a Sketch command, and then I'm going to choose top line. Now, if you look at the top view in a question, you can see that the center point of the geometry or origin of the geometry is located at the center point of the hole. So I'm going to follow the same pattern. To do this, from the Sketch tab, I'm going to choose Circle command, and here I'm going to make a circle right at the origin of the geometry. I also need a second circle as well. Okay. Now, looking at the top view, you can see that the diameter of the inner circle is 9.5 millimeters. So what I can do, I can click on a smart dimension. I select this inner circle and the diameter should be 9.5 millimeter. Okay. Now let's add two lines to the top and the bottom of the geometry. I click on line command, and here I have one line and second line would be here. Now, looking at the top view, we can see that the distance between the top line and the bottom line should be 18 millimeter. It's kind of interesting that this distance is also equal to the diameter of the outer circle. So once I add that distance, I should be having fully defined geometry here because the distance is equal to the diameter of the circle. Let's add that distance. To do this, I click on a Sketch tab. Then I select the smart dimension and I select this line, and this distance should be 18 millimeter. And now you can see that the geometry is shown with black color, which means it's fully defined. Okay, awesome. Let's add more lines to this geometry now. I click on line command, and then here I'm gonna make a line here. Looking at the top view, we can see that we have a fillet in this corner. So what I can do, again, I can click on the Sketch tab and select fillet command. The radius that I want is 4 millimeters. So I select 4 millimeter here. And then I select this point, click OK, and now I have my fillet for the corner. Okay, awesome. Okay, so the next step is to add other features to this location. To do this, I'm going to use arc command. We need 4 arcs and 1 line to complete our geometry. To do this, I'm going to click on the Sketch tab, and then I'm going to choose Arc command. And here I start modeling some arcs. So this is the first one. Second one is this arc. Then I need a line connecting this arc to the third arc. So I need this line here. Then I click on Arc command again. This would be third arc, and finally the fourth one, which is this arc. Okay, awesome. So now we have all these sketches that we want. It's just not looking pretty, of course, because we don't have any sort of relationship or dimension. Let's just start adding some dimensions and relationships. First, I want to start with a relationship. First of all, we need this geometry to be fully closed. So what I can do, I can click on this point, hold Control, click on this point, and now from the options I have, I'm going to choose coincident. And now I have the closed geometry. Next, I'm going to add some tangent relationship. I want my arc to be tangent to this line. So from the options on the left, I'm going to choose tangent. I repeat the process for the first arc and the second arc. I choose tangent again. And then for the second arc and the line, we also need a tangent relationship. So I select tangent. Next step, relationship between this line and the third arc. Same tangent relationship. Then next one is third arc and the fourth arc, tangent relationship. And finally, I'm going to have tangent relationship between this horizontal line and the arc here. So I select tangent. Okay, now we have tangent relationships everywhere. Next step is to add radius to each of these arcs. Let's just start with the first one. The first one is this one. So I'm going to click on the smart dimension. The radius of this arc, according to the drawing, should be 5 millimeters. So I select it and I add 5 millimeter. Same things for this arc, it should be 5 millimeter. Third arc should be 5 millimeter as well. And the last one should be 2.5 millimeter. Okay, so now I have dimensions added to this geometry. What's next? We also need another relationship to define this geometry. If you look at the drawing or the 3D model, you can see that we have consistent widths across the geometry. In other words, this arc should be in line with this line. We don't want this arc to be here. It should be actually in line with this line so that we have consistent widths across our geometry. So what I can do, I can click on the sketch tab and then I select a point command, and then I'm going to add a point here right underneath the center point of the arc. This point is only to help me with adding relationships and dimension. Next, I'm going to select this point. I hold Control, I select this line, and then from the options I'm going to choose coincident relationship. And now you can see the arc was moved such that we have this point and the line to be in the same line. Okay, that's great. Now we still have two more dimensions that we can add. The first one is the angle between this line and this line. So let's add that angle. I click on the angle, I click on the black line here, and this angle should be 12 degree. So I add 12 degree here. Okay. Next, we know that the distance between the center point of the second arc and the third arc should be 22.5 millimeter. So to add this dimension, from the sketch tab, I'm going to click on the smart dimension. I click on this point, I click on this point, and the distance that you see here must be 22.5 millimeter. Now there's another dimension in a different view. If you look at the front view in the drawing, you can see that the overall length of the part is 101 millimeter. So let's add that dimension. Because I want to add dimension from this line to the circle, again, it's easier for me to use a point as a reference point to help me with adding dimension. So what I can do, I click on a sketch, I select point, and I'm going to add 1 point in this location, right in line with the center point of the holes. And now from the sketch tab, I click on the smart dimension, I select the point, I select this wall, and this distance, which is equivalent to the overall length of the geometry, should be 101 millimeter. Okay, awesome. Okay, so now you can see that we added every single dimensions in a geometry, but still the geometry is not fully defined. Let's check our drawing again to see if we can find any sort of dimensions or relationship. Looking at the question, you can see that we added radius here, radius 5, 2.5, 12 degree, this distance, the radius. Thickness is not important here. 18 millimeter distance and the diameter are added to the geometry. We also use the overall lengths in the geometry, but still our geometry is not fully defined. So we need to find a new assumption here. Again, this is one of those circumstances that I explained before. I think in a previous chapter, chapter 1 of these questions, we've had 2 questions that we had to make assumption to help us with having a fully defined geometry. Otherwise, we won't have fully defined geometry. So what we need to do, we need to make a reasonable assumption here to allow us to continue with solving this question. So what can we find in this question? If you're looking at the arcs that we have here, again, these plus signs that you see, these are center points of the arcs. And now, if you focus on arc number 2 and arc number 4 here, you can see the center point of arc number 2 is in line with center point of arc number 1. So we have to make some sort of assumption. And when I'm looking at this geometry, I see this as the most reasonable assumption we can make. So let's add this constraint to our geometry and see if this can help us to have a fully defined geometry. So to do this, I'm going to select this center point. I hold Control, I select this center point, and from the options I have, I'm going to choose horizontal relationship. And now you can see the geometry is fully defined. Again, this was an assumption that we made. It doesn't mean that it's necessarily correct. This is the best we can do. If you're in a situation in exam that you think the question is not fully defined, you need to make a reasonable assumption. And in this case, this is the assumption I chose to make. If you have any feedback regarding this assumption or you think we're missing a point, please add comment and let me know. So now with this assumption, we have a fully defined geometry. We are ready to make extrusion. But before that, we need to make an offset to make the edge of the geometry. So let's focus on that part first, and then we go to the next step, which is using extruded boss feature. First of all, when I'm looking at this geometry, because I want to have extrusion everywhere, what I can do, I can get rid of this part of the curve. I really don't need this part. So what I can do, from the Sketch tab, I can click on Trim Entities, and I select Power Trim, and this tool helps me to remove unnecessary line. So I can click here, I select the line, and the line is gone. Okay, that's great. Now our 2D sketch is ready to use offset. Remember this, whenever you're dealing with the constant thickness across your geometry, it's always wise to use offset feature. Offset is an easy tool to give you the thickness that you want. Now we know that in this geometry, we have the edge of the geometry with a thickness of 1 millimeter, which is same everywhere. So I can use offset tool to make that edge. So let's do that. In order to do this, from a Sketch tab, I'm going to select Offset Entities. And then here I know that the offset I want should be 1 millimeter. So this is 1 millimeter. Make sure Select Chain is selected. This makes your job much easier. Now I select one line. Now you can see SolidWorks automatically selected a chain and the offset line is shown with yellow. I know that the offset should be in reverse direction. So what I can do from the options I have here, I'm going to choose reverse. And then I click OK, and now I have the edge that I want with 1 millimeter thickness. So now this is our 2D sketch. We are ready to use the extruded boss feature to make the final geometry. In order to do that, I'm going to do it in 2 steps. First, I'm going to use extruded boss feature to extrude the geometry everywhere with the same thickness. And then in the next step, I'm going to focus only on the edge and make that extruded edge. So if you look at the geometry in question, the overall height of the geometry is 11 millimeter. But the height of the edge is 1 millimeter from each side. That means if I subtract 2 millimeter from 11 millimeter, the constant thickness that we should have everywhere in the geometry should be 9 millimeter. So I'm going to click on Feature tab, I click on Extruded Boss, and here I'm going to select first contour and second contour. Because I want to have some sort of symmetric extrusion, from the options I have here in a drop-down menu, I'm going to choose Meet Plane. And here, as I mentioned, the total height is 11 millimeter, but we know that 2 millimeter is dedicated for the edges. So I'm going to extrude everything by 11 minus 2, which is 9 millimeter. And I hit enter. Now you can see that we have same thickness everywhere, 9 millimeter. Now it's time to focus on the edge of the geometry. To do this, I click on Extruded Bus. From Model 3 you see here, I select Extruded Bus 1, I activate the sketch, and this time I only select the edge. And the height of the extrusion should be 11 millimeter. I click OK, and now that's our final geometry. You can see that we have the normal thickness, which is 9 millimeter everywhere, and the edge thickness, which is 1 millimeter, and the edge height is also 1 millimeter. Okay, awesome. So now this is our final geometry. It's time to check the total volume and see if our assumption was correct or not. Let's check the total volume provided in the question. In the question, the total volume is shown to be 13,031 cubic millimeters. Let's go back to SolidWorks and check the total volume. So in SolidWorks, in order to find the total volume, we are going to click on Evaluate, and then I choose Mass Properties. And here you can see that the total volume that we found here is 13,011 cubic millimeters. As you can see, this is not exactly same as the number provided in a question, but it's super close. As a matter of fact, let's calculate the difference between this answer and the correct answer. So let me quickly open calculator and check this number. As you can see, we found 13,011 cubic millimeters. The answer is 13,031. The difference is only 20 cubic millimeters. So 20 cubic millimeter divided by 13,011. You can see that the difference is almost 0.1%, which is absolutely nothing. Again, remember, although the question mentioned that the sketch is fully defined, we found that the sketch was not fully defined. So we had to make an assumption. And the assumption that we made was the best we could do. And you can see that with making that assumption, the difference between the answer we found and the final answer is absolutely nothing. It's just 0.1%. To me, this is really acceptable. And I'm really happy with the assumption I made. Okay, I think that's pretty much it. I hope you guys enjoyed this video. If you have any comment or feedback, especially about the assumption that we made, if you have any other solution, please leave comment down below. Thanks again for watching. My name is Ruzbe. Hope to see you again soon in the next videos.